Good afternoon, everyone. This is Mehte Monzu Rosana from Group 10, and today I'll be presenting my project, which is predicting depression among university students using demographic and academic factors. I'd like to highlight how machine learning can help identify at risk students early and support timely interventions. So I'll start with the problem statement part. So, many university students face mental health problems that affect their studies and life, but schools don't have tools to spot and help them early. The research question comes that which students factors actually relate to depression, whether it can be predicted using machine learning models or which will be more accurate and how these models actually can support mental health in education. My project objective is that it aims to actually clean and analyze student mental health data, study its links, academic factors, and build and evaluate machine learning models to predict depression and provide actually practical insights for support. For my literature review, I have actually reviewed for like 6 papers, and in those papers, uh, it is saying that machine learning can effectively predict student mental health, addressing limitations of traditional screening and supporting early data-driven interventions. I have collected this data set from Kaggle, which is a public repository, and the fact is that this data set was very small with only 101 rows, so it was very challenging for us to work with this data set. I have done all the data pre-processing parts. So I'd like to share my codes with you guys so that you have a clear idea about my project. So I have done column name standardization. I can see let you guys see in the code. So the column names was really lengthy and it had question marks and spaces. So I have actually renamed those with shorter, clear, and uniform names to improve readability and reduce errors during analysis and modeling. Then, for the null values, I have seen that only the H column had one null value, so I have replaced that with the mean value. You can also see this in my report that I have handled the missing value analysis. Then for the courses part, I have seen that initially the unique values in the course were 41, but many courses had name like engine or laws, which will be like engineering or law. So I have handled that. Also a lot of courses had capitalization problems, so I had strived that. So the unique numbers of the courses came down from 49 to 37. So it was a very important part of my data pre-processing. And I have also cleaned the year value by removing non-numeric characters and converted it into integers. And I have checked unique values of all boolean columns and cleaned the GPA column by removing extra spaces to see the actually distinct values. So this was all from my data pre-processing part. And for the modeling part, we have actually run 6 models, and I have run these 3 models: logistic regression, decision tree, and KNN. So you can see from the score that the best model here was logistic regression. It actually got accuracy of 80%. It was because it comes from the dataset being very small and having mostly linearly separable relationships between features and depression. And the worst model was KNN, with low accuracy of 58%, poor precision recall, and F1 score. This is likely because KNN struggles with small data sets and can be sensitive to noise and making it harder to capture meaningful patterns. So this was all from the modeling side. So a question actually comes up that how can we improve these facts? So we can try actually cross validation instead of single split for more reliable results, and we can actually collect more data to make our data set more big or lengthy. So that was all from my side. Now my partner will sum up his part. Thank you, everyone.
Good evening, everyone. Basically, I'll start from exploratory data analysis. Here we go from gender analysis. So, female student reported higher rates of depression, anxiety, and panic attacks, which aligns the global trends showing females are more vulnerable to mental disorders. If we see the marital status correlation, depression shows 0.60 correlation with marital status and highest in our entire data. Married students are significantly more likely to have depression due to balancing family life with academic demands. And if we see the academic performance sector, GPA showed very weak correlation with mental health, meaning students suffer silently while maintaining acceptable grades. We cannot rely on academic performance alone to identify struggle students. Course specific patterns, engineering students shows 11 that vulnerability due to demanding curriculum, while BIT and KUE students reported the highest anxiety levels. There is another relation between CGPA risk students with 2.50 to 2.99 CGPA experience the highest depression rate, creating a U-shaped relationship. This suggests academic uncertainty creates particular stress. These students are neither confident in their success nor resigned to a struggle. So if we see the machine learning models, we have implemented 6 model: logistic regression, KNN, decision tree, random forest, gradient boosting, and NAPS. And if we comparison among these models, I'll comparison among 3 models because I have implemented these 3 models. Random forest, 83% accuracy. Disassemble method builds 100 decision trees and combines their predictions. Dovuti, it captures complex patterns and provides stable results, but couldn't fully leverage its power with only 100 of 1 samples. And gradient boosting, 83% accuracy. This sequential assemble techniques learns from previous mistakes. We know that while each tree corrects error from the last one, it excels at handling difficult to classify cases, though gradient descent optimization. And last, the naive bias, 90% accuracy based performer here. Based on naive bias, this probabilistic models achieve 100% precision and 73% equals and 84% F1 score. It on because effectively captured probabilistic relationships in our small dataset, and the 100% precision means zero false performance. So the performance logic could be mental health is a multifactorial with complex interaction between demographic and academics. Ensembles method generally outperforms a single classifier, but with our limited data of 100 of 1 students, the sample and a bias model owned by effectively handling the probabilistic nature of our features. So here we see the statistical significance and practical implementations. So if we see that our 90% in real world impact, if we see our 90% accuracy means that for a university with 10,000 students, this model could correctly identify approximately 800 students additional at risk students compared to random students. The 73% recall, the 100% recall is successfully identify the maximum experience depressions, which is crucial because missing a depressed student has far more serious consequences than incorrectly flagged healthy student. So, in the term 100% recalls, we can successfully identify the maximum students with depression. University application, we can see universities can deploy automated screening during enrollment, proactively reach out to uh, high risk and allocate mental health resources more effectively based on predicted demand. So if we see the part discussion at the first one, the key findings: female and married students faced disproportionate mental health challenges. Mid-range CGPA students 2.50 to 2.99 show highest depression rates with U-shaped relationship, which we see in past in our correlation heat maps. And engineering students shows elevated vulnerability due to demanding curriculum. If we see the why this work is better, we have achieved 90% accuracy with name bias. So 90% accuracy with naive bias. So the highest among all model tested, all model tested research, and unlike similar studies, we compared 6 different algorithms comprehensively instead of just 1 or 2. Our balance matrix of 100% precision and 73% recall ensure both accuracy and minimal missed cases, making it practical for real universities implementations. with ethical consideration. So if you see the practical application in university, so we can say that deploy automated screening system during enrollment and regular intervals, proactively reach out to high risk students identified by the model, allocated mental health resources efficiently based on predicted demands, and the remediation parts our data set of 100 of one students in relatively small and needs validation with large population, and self-reported mental health data may be affected by social disability bias and missing potentially important variables like socioeconomic status, sleeping patterns, and family history. And if we see the part of ethical consideration, student privacy and data security must be rigorously protected, and predictions should be used for to offer support, not to stigmatize or discriminate against students, which we already done. And future work, if we see, and the conclusion point, if we see the training with larger diverse datasets for multiple institutions and geographical areas, and conducting longitudinal studies that track students over multiple semester. And in conclusion parts, we can say that the study established that data driven mental health screening is both viable and valuable. The naive Bayes model 90% accuracy proves we can identify at risk students before crisis occur. The goal is not to replace counselors, but to augment their capabilities with intelligent tools that enable earlier, more targeted, and more effectively supported. Thank you, Pierre. Hope you get everything.